Hello friends, we will learn about how to predict the value of dependent variable in case of a log-LIN model. So as you can see here, we are having a log-LIN model where the dependent variable is salary, and this is expressed in terms of log, but experience is expressed in terms of linear. So, uh, many of us actually find the trouble uh, in interpreting and predicting the value of salary, and you can expect 2 to 3 kind of questions. So how we are going to predict if you get log-LIN model in the exams? So at first we'll look into the value of salary when experience value, that is someone is having 0 experience and someone is having 5 years experience. Okay, first we'll find out, then second, in the second question we'll have to find out the percentage increase in salary. Okay, and here percentage increase in salary, that means we are looking into the change in the log value of salary. Okay, times 100. So the percentage change or percentage increase in salary when we are taking the log value, and when the experience is increasing by 5 years from 0, and then we'll use this result to compare the part in C, where you are going to compute the exact percentage difference in salary when experience goes by 5 years from nil years. Okay, so what is the difference if you see, if you ask? So the difference is, here we are looking at the change in the log value of salary, but here we are actually looking into the difference in salary, and that exchange, sorry, that percentage change, in percentage difference in the salary. Okay, so these two are different things, two different things. So let's at first let's find out the experience equal to 0, then what is the value of salary. Okay, so this is simple actually. When we are going to look for the predicted value of the dependent variable, the rule is exponential to the power of log of x. So your x is your salary, so let's keep that salary. Okay, so at first we are taking when the experience is equal to 0. When experience equal to 0, what is the salary? Then we know that they have given the relation between this salary and work experience, that is 10.6 plus 0.027 and experience, right? So we are putting 0 in terms of experience, so we are putting this 10.6 years, and now we are having this 10.6, and so exponential value to the power 10.6. Okay, so this is your log of salary value, and you're getting the predicted value for this salary. Okay, and this is the method that you put the values into the model. This is the log-LIN model. Okay, this is the log-LIN model. Okay, let me, I think I just made a mistake over here for this. Sorry, I wrote it. I hope it's visible to you now. Yeah. Okay. So exponential to the part this log of salary value, that is 10.6, and we will find this out using any scientific calculator, or put this value in the Google, and that will throw up a value. Okay, so this is quite simple, and you get it. The value will be exponential to the power 10.6 will be 40,134.84 dollar. Suppose you are using dollar. Okay, so this is the value. Now we are going to look for log of salary when there are 5 years of experience. Okay, so then you just put the value 10.6 plus 0.027 times 5, so it will be equal to 10.6 plus 0.135. This will be equal to your 10.735. Okay, and now you take the value of exponential to the power this log of salary 5, that is log salary when the work experience is 5 years, so it is exponent to the power 10.735. Okay, so this will give you a value of 45,935.8. Okay, so you can see when zero experience, the salary is predicted as $40,134, and this is when there is the 5 years experience. Okay, salary. Now question number B is, now we are going to use the equation that percentage increase in salary, and that is percentage change in log of x times 100. So what is this percentage log of log x? What you are going to find out that your log x, you have already found these two values, 10.6 and 10.735. Fine. So you just take the difference between this and use the multiplying this by 100. So this will be 100 times 10.735 minus 10.6 will be equal to 100 into 0.135, that will be equal to 13.5%. Okay, so this is the percentage increase in salary, when, so this is the formula we have used. Okay, now we are going to look at the exact percentage difference in salary. So when we are talking about the difference in salary, then you have to take the value of salary first, then you have to take the difference among them, and then you find out the percentage change. Fine. So there are two different things. So B is asking for the percentage increase in salary by using the del log x times 100, but here we are looking at the exact percentage difference in salary. So for that you have to know the salaries first. So we have already got these two salary values. Okay, so these two salary values we have to look into. So this is question C, and this will be 100 times the highest one will be 45,935.8 dollar minus 4134.84, and this the original value, that is 4134.84. Okay, so this will give you the exact percentage difference in the salary. So this will come up 100 into 5800.96, okay, divided by 4134.84. So it will all come up to 14.45%. Okay, so you can see this B and C, they are giving two different result, right? Here you are getting 13.5%, and here you are getting 14.45%, so exactly 1 point difference. 1 percentage point higher when you are considering the percentage difference in salary. Okay, so this is it. We'll continue this series. Thank you very much.